Well, hello, hello. Welcome to the fucking. What is this? Can I stream key? Oh, huh. Oh, okay. Well, I guess I can't stream. Oh well, I can record. Man, stream Twitch or something. Well, anyway, welcome to another of Professor Irvin's lessons of artificial intelligence and its applications. Oh, it's got what's me my hot cocoa and my cat is not here, but eventually she does be here. And mm, ooh, 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 ooh. Oh, that's too much. That's too hot. Oh, which we're discussing that later, by the way. All right, let's get dirty. All right, in this lesson, I think I'll make it like all in three instead of just one of each, because I don't think I can do one lesson per 50 minutes. I think it's awfully too short. So, what's this? What is that? I don't. I, I don't get it. What? Huh. Anyway, all right. In these lessons, we're gonna learn about artificial intelligence, and these are the topics we're gonna discuss for today. Maybe, which is one is crime. And I misspelled crime. Way to go, me. We're gonna talk about government. So it's AI and crime, AI and government, and energy. I'm pretty sure I'm missing something. I think energy was number four. This is what happens when you don't write down shit. Maybe it'll come to me later. All right. Good. All right. Let's start. First, I want to talk about crime. All right. Now, how's this going to play with artificial intelligence? Well, if you get it to program in a certain way, it'll be a very effective detective. Now, I'll show you why. Now, from what I learned, I think, or I made up, is when a let's just say when a homicide happens, all right, you want it to program as the victim. Let's put the victim in the middle as the suspect. So if the victim calls the police or any of that sorts, or the murder happens, the victim is always the suspect first. Unless you can prove otherwise that it wasn't the victim after all that did the crime. Because it happens all the time too. So this is the most inner part right here. Alright? The victim will always be the suspect until it's proven somehow. Okay, the next layer is like a little orbit. Immediate family. Was it the pop? Was it the mom that killed the victim, or was it the best friend or the lover? It's usually the lovers a lot of times that did the killing or multiple killings. All right, this is the family here. Once it discovers it's not that, then you go to the next layer. Whoop, work. What did it happen? Was it something related at work that caused the victim to kill or to be killed? Was it anything work related? Did was it a mass layoff? Or was he sleeping with the boss and the boss was like, I'm gonna kill you now. Or 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 any other work related stuff that might have caused the victim or the suspect to go super crazy. Like maybe he lost the lottery work lottery thing that they do, or maybe he had a crush on someone at work, or maybe the work just drove him crazy eventually. All right. Now, once that's settled, and what the heck did I do? Once you figure out that it's not work related, then you go up to the one next level, which is citywide. All right, the city. The anything around the city that caused a victim to be killed or get killed or go crazy. Was there like a festival that made him go nuts? Maybe he's afraid of gay people and he saw a gay pride, the gay pride thing, and he's like, oh no, oh no, I can't have that, Mister. Oh no, no sorry, nope. And he went nuts, or he was in a dark alley and got killed over there, or he killed a homeless person. That happened around the city, or or maybe he went postal. Maybe he doesn't like the post office. That's city level ish. All right. Once I figured out it's not that related, maybe it's state level. This is usually the highest, which is like, did a war happen, or the North Korea invaded that caused the victim to get killed or kill? Maybe nuts, or is there a secret lover in Venezuela? I'm gonna go nuts. Anything that's happened in like in a country level. Did a war happen, or was it a civil war that caused the victim to get killed? To figure out this homicide thing. All right. Now, usually there's one more layer, which is unlikely to happen, and it's the extraterrestrial level. Did a comet happen that caused him to get killed, or to kill or be killed, or a comet, or a meteor, or aliens came by and invaded us, and then aliens killed the victim, or the victim killed the aliens? It's the extraterrestrial level. I cannot spell it. This is the last level layer. All right. Once you figure out if it's not the victim, that's not the suspect, and you go to the family. Was a mom and pop, or the lover, or is it work related, or maybe he got fired, or got laid off, or sleeping with the boss, or maybe it's at city level that he killed a homeless guy, or maybe a homeless guy killed him, or maybe it's at state level, or North Korea invaded, or nuked, or someone nuked the city, or maybe it's extraterrestrial and maybe got hit by a meteor, or aliens want to probe his ass, or vice versa. So that's basically how you solve a mystery, uh, logical wise. How would a machine would figure out how to solve a crime. That's pretty much it. So that's crime right there. That took me almost 9 minutes to explain it. Cool. I'm gonna roll. Mm, good hot chocolate. Let's go to previous. I forgot what the government. Oh, government. Here's an interesting one. Government and AI. When the AI governs the people, and not the people governing other people. Actually, what that be called? I've always been wondering what would it be called. Would it be called a autonomocracy, or a cyberocracy, or a machineocracy? Something that will mean rule by the machines, or rule by artificial intelligence. That will be the system of government. Now, I suppose if you can convert the Constitution and then convert it into ones and zeros for the AI, I'd be like, oh yeah, yeah, you can't do that. No, that's a no. That's a naughty thing to do. Kind of like Isaac Asimov's story AI. That kind of works its way in with the how to put AI in a governmental role, have it control nukes, or no, that's a bad idea. Don't let it control nukes, or diplomacy with the other countries, or or how to fix our domestic affairs, cure homelessness and all that junk. And apparently, that's all I talk about the government. I mean, it should be easy. I mean, how to feed data to what we need it to do. All right, fix our unemployment and our money. Ooh, money, economics. Mm. AI in economics. Like handle our currency. That's one. Part of the government role is handle our currency in our economy. So it'll control. So it's kind of communistic in a way. It controls our currency. It'll control our economy. It'll control our production, and it distributes what we need, all the resources what we need for all our citizens to be happy. And it turns out I don't have much to say about government at the moment. Huh? Maybe I need some backup here. Got this what we call grape juice plus that might not joggle my noggin here in a bit. Well, I'm drinking my hot cocoa. So warm. Energy. Hmm. Speaking of energy. Hmm. Ah, yes. Speaking of energy, AI and energy. Yes. If we can figure, if we were to convert how making AI understand energy, that'll be a goal changer. We can get off this fucking planet for one. We can't get out of planet Earth with just oil. See, so far we got fire. This is what we have currently, and then we have steam, right? And we have nuclear, all right? And we have fossil fuels like oil or methane. Oh, speaking of methane, like on my last video, I made a mistake. I'll talk about that later. I'll put this little line to explain that later. If we can get the AI to behave like us, the way how we extract energy from resources, we can get out of here. We have a little boost. We can get off this planet and start colonizing other planets. Or here's a something that'll blow your mind. Mm. Or we can have our planet Earth to be converted into a spaceship. We can convert our whole planet and turn it into a spaceship, and we use the core of the Earth as energy, and we can boost on out of here this planet. as our sun expands and exhausts itself of its resources, and it goes boom boom. It goes. That's the sun. It goes boom. But we'll be safe because we're like, hey, I see ya. We converted our plane into a spaceship. Bye bye. But maybe we could, in the meantime, as we're all procrastinators, we gotta start now. We got about I don't know 600 million years, or maybe it's close to a billion, to where it gets hot enough to boil our oceans away. The sun won't blow up until like another couple billions, but in the first billion years, it'll get hot enough that our oceans will just go away, and we don't want to do that. But in the meantime, if we can figure out a way to store all that energy from the sun and just put in our planet and store it while we build our awesome super spaceship and have it stored all the sun stuff into like special batteries or some sorts. Or do it this way: put a Dyson sphere on our sun and then have that grab all the energy and then store it in our future spaceship Earth. In the meantime, give it about 400 million years to store all that power. And about a time on the 600 millionth year, we'll be ready to go. And then we can go, we get out of here, taking our planet with us. And then maybe we can start colonizing other planets too. Why not? We'll have two giant spaceships so we can convert from planets. That'd be kind of cool. Mm-hmm. And we can populate the rest of our galaxy with our seeds of sperm. A whole galaxy and in the universe. And we can live happily, happily ever after. But wait, there's more. Oh, wait. Before I say that. Uh, wait, there's more. Gotta remind myself. I gotta explain this about the methane thing. Remember how I said it was like, what was it? It was like CH4. And then I was like, well, that shit turns into like carbon dioxide and then H2O. But then I was like, okay, well, where does the rest of the H2 go? Oh wait, I forgot to put the O2 in there. And this combusts, and the byproducts are carbon dioxide and H2O. And I was like, well, where does this H2 go? And I was like, well, maybe it just fizzles out with the energy. But I was wrong! I was wrong. Sorry for yelling. I was wrong. I was I was talking about my ass. I still am, but I'm not talking as much of my ass. All right, look, check this shit out. It's CH4. Okay, two of oxygen, and then combusts, and then it goes carbon dioxide and two H2O. So it turns out I just need to put more oxygen, and then to turn it into water, to have a complete water. But this is like assuming this is a perfect combustion. Now, now if it's incomplete, this shit happens. So it's like CH4, and then what was it? O2, right? And then it combusts, and then you have carbon monoxide, which is poisonous to us, and then H2O. Wait, there's four hydrogen. Hold on a minute. H2O. Okay, so there's more H2Os. H2, H2. Okay, yeah, so it goes carbon monoxide and two particles of H2O, which is something you don't want. This is poisonous to us. Incomplete combustion is what they call it. Wait, how many oxygen is this? That's three oxygen. So it's like what? It's like O2 and O? One, two. So it's one part oxygen and two oxygen? Is that how it works? I don't think so. See, I'm still talking my ass. Mm. Well, it's something like that. Maybe I'll make a second version of this whole syllabi that I'm got going here out of out of wing. I mean winging it all. Yeah. Mm. Well, all right. Now this thing here. The part of it says wait, there's more. Mm. There's a catch about this whole energy thing. That maybe the AI would have this figured this out for us. Mm. It's called entropy. Now, what is entropy? It took me a while to understand entropy, but basically, it's part of the one of the laws of thermodynamics. Second law, to be precise, it states, uh, uh, oh shit, I know the other part where entropy only increases. That's part of the second law. Entropy only increases. Disorder goes up. It always increases as the heat, goes to a colder place. Mhm. Mhm. Mm. Oh, that's all I'm gonna drink. All right, I'll show you this. If you still don't understand what entropy is. All right. Here's an example. Imagine my mug, my hot cocoa mug. All right. Here's the mug. All right. Here's the handle, and here's the steamy. That's hot. All right. These arrows is heat. It's like circulating stuff. It's hot. All right. Well, here. This is a table. Okay. Now, the heat always wants to go where the colder place is. So you get some heat transferring out, making the table go warmer and making the air go warmer. It'll go here. It'll travel outwards. To here. Oh, let's see. Oh, I just remember now. Part of the second law. There's like a its main goal is to make everything in the same temperature. Make everything the whole universe at the same temperature as it always increase. I think that was the other part. So you got here. By the way, there's no such thing as unlimited energy. By the way, so if you ever watch a YouTube video that someone has like, hey, I forgot unlimited energy, it's a fake, it's a farce, it's bullshit, and I'm here to tell you why. Oh yeah, the cup. I got distracted. See, as it moves away from the cup starts to get cooler. It starts to become the same temperature as the room temperature, as all the all the heat that's dissipating is moving to the colder parts until it becomes the same temperature. It dissipates. All energy, all heat goes to cold. Always does. It doesn't go the other way around. We wish it did, but it doesn't work that way. Another example is let's see. is a refrigerator. How it cools inside by by coils. The condenser coils here, and then you got the evaporator coils inside that removes heat, and you got the condenser coils that poops out heat, that transfers heat and poops it outside, and then in progress it cools what's inside the fridge. Here's pooping out. Here's some heat. It goes the evaporator, sucks up the uh, the heat. The refrigerant does. It sucks up the heat by the refrigerant. It transfers the heat and spits it back out to the universe. Now to do that, it requires energy. And that energy is electricity. It needs electricity to do this. So you're bringing in energy via electricity. That shit turns on. It pumps out the heat, and the heat goes out, and then therefore cooling what's inside the refrigerator. Just as long as it's having energy from the outside going in, as long as the energy is being provided via electricity, it does the job. And then, without breaking the second law of thermodynamics, it spits out to the universe, to the room, therefore increasing entropy. I hope I'm very explaining this very, very so well. Break. I get my grape juice plus. You didn't hear that? Smells good. Hey, I got plenty of it. Mm-hmm. Ow, ow, that hurts. Little metal things. Pot you get a cup. Mm, 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 mm. It's pretty good. Mm-hmm. Good, delicious grape juice. Mm. Plus. Mm-hmm. All right. Let's talk about more about entropy. Okay. Now, energy. Well, this is the first law. Energy cannot be destroyed or created. It's just transfers. Keep that in mind. All right. Okay. Let's just pretend the room that's in. Okay, this is the room, and here's the fridge, and more red arrows is the heat transferring out. As the refrigerator is cooling inside, more heat is going out. And as there's more heat going in this room, it's kind of equalizing the temperature. Make it just lukewarm, just warm. Oh yeah, this is happening too. Pretend this is the outside of the house. As it's doing that, more heat is going outwards. Because remember, heat always goes where the cold air is. So it's just going to keep doing that. So it goes from the fridge, it goes out of the fridge, and it goes in the room, and then out from the room, it goes out of the house, and then out of the house, it goes to outer space. Or maybe it bounces back because of the greenhouse effect, and then eventually it goes back out again. Because it will go back out eventually. And it goes out to the universe. And it keeps going. Try and move those colder ears of the universe. Let's get a bigger picture. Pretend this whole blue area is the universe. And it's expanding, by the way. And here's the... Ooh, got the wrong color. And here's the heat. It's just spreading out. Just outwards in the universe. Just going outwards. It's going out. Well, now here's the problem about the second law. One of the bad parts. As the universe expands, so does the energy continue going outward. And as to do that, as it gets bigger, the inner parts it actually permanently loses energy. It's because it's so spread out. It's just it goes. The energy is just there's not as much energy as it used to be because all the energy is going away. As the universe expands, more space is in between, and it's just gonna keep going outward. It's just gonna all spread apart. Over time, it's just gonna wane of energy. It's just gonna go whoop. It's just gonna go out. This is bad for us. Bad for us because when there's no energy, we cease to exist. We all die. The whole universe will die too. Let's go for in the future. All right, oh, wrong color again. Yeah, just making a page. Whee! All right. Now pretend this is the energy. Just spread it out. Okay. This green part is us. This is our clusters of galaxies. And here's the energy. Just this energy used to be over there, but now it's still spread apart as the space is expanding. So is the energy. It's just going away, and all whatever energy is left in our little clusters of galaxies here is just that's all that's left, and it still goes out, and we're still losing energy as it goes out, spread out. People say it's spread out because this thing called dark matter is what's doing it. See, it's spread out, spread out. Everything's getting the same temperature at the same time too. Out, out. Let's go further in the future. Whoop. Still going out. They're so spread apart. And then here's our where we're at. At this point, all the stars are just starting to disappear. As stars dies, there's not as much new stars to make new stars because the heat, the leftover heat is gone. The energy is just gone. There's not enough movement to create new stars. We got gravity, but there's no energy to like keep it, keep make work to do work. And that's gone. And then we're stuck in another planet. Whatever energy we have left right here, that's all we have. As we see the stars just disappearing and dying. And we're using up all the elements. Like uranium. Uranium has stored energy. We've been using those. Any other elements that's higher than uranium or hydrogen. Because once that's gone, once it's combusts, once we use that energy, the leftover heat is just it goes bye bye. As the universe starts going bigger and bigger, more of this is just starts go away, and we're losing all that energy permanently. We're losing that energy. Once that energy's gone, it's gone. It's bye bye. Let's go further in the future. This is us. All right, this is us. Whatever energy we have left is within us, and whatever elements we have left, everything else is all pure black. And whatever energy we have is in our resources, whatever's left in our core in the planet. Oh yeah, this is our spaceship. Now our spaceship no longer works. We ran out of energy because there's not enough energy to move the planet, our planet spaceship to go. So that don't exist. That's gone. There's not enough energy to move our big spaceship. Now it just drifts. It just drifts into the eternal blackness. As us right here, our planet, whatever energy we have left is in our own resources, our own elements. Whatever hydrogen left we got, whatever oxygen we have left, whatever ways we can keep the place warm. The warmth inside our planet is waning. There's not enough energy. It's running out. You know that furnace we got going on? Well, we're gonna run out of natural gas and that heat. Once we expend that energy, that heat that's going to furnace is going outside the planet, our spaceship planet. It's going to go right through, and it's just going to go out. And as the universe expands, it's going to make it worse. It's going to be more spread out. And we're never going to see that energy again. It goes spread out. It's waning. Our planet spaceship is just out of energy. It's going away. It's gone away. Now let's go further in the future. Black holes are just even the black holes they disappear too. They run out of energy. It evaporates. And here's our planet Earth. Our planet Earth. And here's a little planet. And here's us. Pretend we are still alive. We're just looking. Now we're just getting kind of cold. We're using whatever resources we have left. And the planet Earth is getting colder as the rest of the universe is getting colder. We're all getting colder. Uranium is depleted. The carbon's depleted. Our hydrogen is almost depleted. Our oxygen's almost depleted. Whatever things we do, warm ourselves up, or stuff we make food out of. When we use that energy, heat goes out. Now it's just so spread apart. It goes out. We're losing even more energy. It's too spread apart. As the universe expands, it's getting too spread apart. It's going. It's going to spread apart. No. Even more. And we're going to the further future. Boom, boom, boom. Wayne's World style. Here's our spaceship. And here's our planet. It's cold. Here's us. It's getting cold. We're figuring out ways to keep ourselves alive. Everything's depleted. Everything's getting cold. The temperature's going the same all around the rest of the universe. We find some elements here and there. Very, very sparse. So very, very sparse. So very sparse and so very cold. We extract energy for our resources. And our planet's getting cold too. Heck, maybe the electromagnetism inside our iron core is just getting colder. It's just it's gone. Everything's gone. Whatever left. Energy, heat is going away. Even more, way more spread apart. It is just going away. Whatever the energy we have left, it's gone for good. It's too spread apart. It's too spread apart. Here we are. Everything's depleted. Everything's so cold. Maybe it's like negative 45 these days. Maybe let's just assume we figure out a way to withstand that cold. Everything's getting all equilibriumness. The temperature's getting the same. We're just so dry. Everything's exhausted. Everything's getting cold. We don't have the energy. We're just slowly dying. No one to help us. No. Ooh, I found something. Get warm just a little bit. Oh, yep. Ooh, warmth. Pew, and it goes the other energy. What is left? Gone for good. All the plants are long dead. All the animals long dead. Living things are long dead. There's nothing to metabolize. The energy is gone. It's gone. So quiet. So black. So black. Look at the energy. It's just gone. So tiny. Little spurts of energy just gone. So spread apart. So black. Nothing but blackness. Black. Even our own spaceship is starting to just fade away. It's starting to break apart. And it's breaking apart. The elemental decay is just breaking apart. Our planet is just blip, blip, blip. Here you are, the immortal human here. It's just alone. Alone. Nothing. Just bloop, spurts here. You're alone. Gone. Sucks to be immortal. No. Going further in the future. It's just black. Black. It's just you. It's just you. Alone. Nothing you see is black. It's all black. Very cold. And very black. That's all you can see. Pretend you're immortal. It's just you. All your spaceship, the people you know, the Earth, the animals you once knew millions and billions of years ago, trillions years ago, just decayed and just went bye bye. It's just you. Blark. Blark. Blackness. Nothing but blackness. Just dark. Very cold. Alone. You're a god. But what is a god when there's nothing you can do? All you see is blackness. You're immortal. But nothing you can do. You're just stuck in this forever darkness. Trillions of years has passed. You're just floating on pure black darkness. Alone, quiet. And your mind is just fading as you yourself is starting to feel the energy leaving just a little bit. It's gone. Even more spread apart. It's ever expanding. Go back in the future. Here's the universe. The entire universe. Ever expanding. So black. It's been so spread apart. And we're reaching absolute zero. We're getting about we're going to like one, no, we're going to go like 0.00 to 0.00000001 Kelvin. Whereas we're approaching zero, everything's becoming a solid. Like the universe is crystallizing of sorts. And here's you, that little dot. You yourself are slowing down and turning into a crystal-like thing. Your mind is just withering and going, slowing down. You just can't. You're just so sleepy. Everything's black. And the universe is still expanding. And the universe is getting all equaled. Everything's getting equally approaching zero. All equal equilibrium. Everything's getting all the same temperature as it approaches 0 Kelvin. Absolute zero. Trillions and trillions of years has passed. As the energy, all the energy in the universe is just too spread apart to do anything. And the universe just keeps spreading, keeps expanding. Until it is completely 0 Kelvin. Absolute zero. Everything's solid. Nothing's moving. Space and time, actual space and time, will just cease to exist. There is no space and time. It too has stopped. Everything has stopped. The universe declared dead. forever. Dead forever. The end! And that's entropy. In a nutshell. But, get this, without entropy, we, as living beings, won't exist either. We are the result of entropy. Even though even though living things it decreases entropy, but as we decrease entropy, we're still increasing entropy by by eating, by being alive. The heat we generate, it dissipates heat. It increases entropy of the overall universe. Now, what does that do with artificial intelligence? AI with entropy? Well, if there's an AI in our spaceship, Earth spaceship thing, it too is susceptible to entropy. It too is going to die eventually. So it has to figure it out. Maybe our machine can figure out some way to kind of reverse entropy of some sort to save us. It's kind of like that one book, Isaac Asimov, and I can't remember the name of the book. There's a visual novel of it. I highly recommend reading it. Actually, hold on. I think I can go to the web here. Yeah. Okay. Let's see. I think it's like Asimov. It's like a visual comic. Entropy. Is that what that is? Last comment? Last question? I think that's what that is. Hope it's someone you can just where you keep scrolling down. Oh, come on, man. Okay, maybe not. I think it's this one. Yeah, this is it's kind of like this, but it's like a much better website about it. Yeah, it's kind of like that. I highly recommend reading it. It's pretty cool. Hold on here. Whoop. But yeah, it's pretty cool. Now, if we get the artificial intelligence to do this, if we can somehow make a formula to understand entropy and then kind of have it calculate, we got something going on there. That would be cool. Yes. Yes, it would. Mm-hmm. But I don't know how to do that. Maybe you guys could. I just don't know the math, how to do it yet. Oh, I may never will. I never will. Yeah. Oh, what's it doing now? Yeah, it's ignore. Thought I got rid of that. And that's where I'll end the lesson here, folks. So what do we learn here, kids? Learn about energy. Speaking of energy, we learn about entropy. We learn about crime and government. Now there was something I'm missing, and I can't remember. Maybe in the next lesson, I can show you guys how to do that. Well, if you're more interested in this thing, just subscribe, sure, and then you'll learn more as I get to grow more. And maybe my next lesson, I'll show you the actual formula, how to apply it to programming for get this thing started and stiff. But yeah, that's it. Thank you for watching. Ta ta.